Hi everyone, I'm Ty, a student at Macquarie University with a passion for leveraging data to solve real-world problems. I participated in the ArrangoDB GraphRag Hackathon because I'm fascinated by the power of graph databases and AI to unlock insights from complex datasets. Today, I'll walk you through my project, the Disaster Impact Analyzer Agent, built to analyze global disaster events. Let's get started. I've always been interested in how technology can improve disaster response, whether it's predicting impacts or planning actions. The hackathon was a perfect chance to combine my skills in Python, graph analytics, and AI with ArrangoDB's capabilities. For my dataset, I chose the GDELT Open Intelligence Dataset, a massive graph of global events, over 65,000 in my instance, connecting events to actors, locations, and sources. Why? The business problem is clear. Disasters like violence against civilians disrupt communities, and responders need tools to understand these events, predict their ripple effects, and act fast. GDELT's rich relationships and historical scope make it ideal for this challenge. Now, let's dive into how I built it. Section 1. First, I set up my environment, installing Arrango datasets, NX ArrangoDB, LangChain, and NX cuGraphQ12 for GPU analytics, connecting to my local ArrangoDB instance where GDELT is preloaded via Arrango datasets. Section 2. Next, I explored the data. I wrote an AQL query to fetch all events, no limits, grabbing details like dates, fatalities, and geo-coordinates, plus relationships to actors and locations. This pulls in over 65,000 events, which I store in a pandas data frame to check the structure. Section 3. Here's where I convert it to a graph. I build a Network X-directed graph in memory. Events as nodes with attributes like fatalities and geo, linked to actor and location nodes via event actor, and has location edges. Then, I persist it to ArrangoDB as Disaster Graph 1 using NX to ArrangoDB, with a batch size of 10,000 for efficiency. You'll see stats like thousands of nodes and edges, showing the full dataset in action. To give you a sense of the graph, let's visualize it. This pulls all event nodes from Disaster Graph 1 and plots their geo-coordinates with Plotly. Look at this. Thousands of red dots across the globe, each an event like a violent incident in 1997 Algeria. This sample shows the scale and geospatial richness of the data, helping responders spot disaster hotspots instantly. Now, the core of the app, the agent in Section 4. It's powered by LangChain and OpenAI's GPT-4o, dynamically processing natural language queries. Here's how it works. Retrieve events. Uses Arrango GraphQA chain to turn queries like which events had fatalities in January 1997 into AQL, searching the full graph predicted in impact. For queries like what's the impact if event/ALG1 occurs? It copies the graph, removes the event, and uses QGraph or NetworkX if no GPU to predict isolated regions and affected nodes. Plan response. For how to respond to violence in Dawa. It finds related events and computes a shortest path in the graph recent events. Summarizes recent incidents, like last 30 days of 1997, with a historical twist. The agent picks the right tool based on intent, blending graph queries and analytics seamlessly. Let's see it live on Gradio. Here's the interface. First, I'll type, which events had fatalities in January 1997? Show output. It lists events like event/ALG1, a beheading with 5 fatalities. Next, what's the impact if event/ALG1 occurs? It predicts isolated regions and affected nodes. Now, how to respond to violence in Dawa. a plan with a path to address the event. Finally, what events happened in the last 30 days of 1997? A summary of incidents. That's the Disaster Impact Analyzer agent. It tackles a real business problem with innovative graph analytics built on ArrangoDB's strengths. Check out the code on GitHub, insert URL, and let me know your thoughts in the comments. Thanks to ArrangoDB for this awesome hackathon. Hope you enjoyed the demo. Please like and subscribe for more.